Welcome to the Structural Analysis 2 video lecture. So in this lecture, let us discuss a problem on a train of loads. A train of loads, that means a sequence of different loads, preferably point loads here. So this is called as train of loads. So the system of concentrated loads or a train of loads both means the same. So here as shown in the figure, they are rolling from A to B of span 15 meters. So they are rolling from A to B. So this end is B actually. So it's a span of 15 meters. Overall span is 4 plus 1, 15 meters. So determine the maximum shear force at C. So at C we have to determine the maximum shear force. So first we have to know that this is traveling from A to B. That means 40 kilonewton load will cross C point first. Next 50 kilonewton load will cross at a distance of 1 meters, and next 60 will cross at 2 meter distance, and one more 60 kilonewton load will cross at 1.5 meters, and 20 kilonewton will pass at 1.5 meters. So we have a condition to find the maximum shear force at any point, say C or B, whatever. So that condition is load rolled off section divided by succeeding span must be greater than the remaining loads by whole span of girder. So first 40 kilonewton load will roll off that section. That means it will cross that section C. So that is 40, and the succeeding span, that means 40 kilonewton load and the next load, this is called as a succeeding span, that is 1 meter. So here it is written as 1 meter, must be greater than remaining loads, addition of the remaining loads divided by whole span of the girder. This is the whole span of girder, not the span of the train of loads, and here it is succeeding span of train of loads. Here we have to be careful. So here, 40 by 1 greater than the summation of loads. So this condition is satisfied as 40 greater than 12.67. Yes, so this is satisfied. Now we can use 40 kilonewton load on point C to find the maximum shear force at C. So according to the condition, by keeping that 40 kilonewton load on C, we can find the maximum shear force at C. So if we draw the shear force, the influence line diagram for the shear force, it would be like this. So if it is 40 here and at 1 meter distance, there will be a 50 kilonewton load as per the train of loads, and at 60 kilonewton there will be a 2 meters, and here there will be, after this, there will be a 60 and 30 that will not start on the girder according to the train of loads, because we are keeping 40 kilonewton load at C. So we cannot consider this 60 and 30 which are the extremes which will not start coming on to the beam. So according to the influence line diagram for shear force, we know very well that at a point where we have to find the influence line, the shear force is considered there. It will be a positive and negative thing, and we have to draw the shear influence line diagram for the shear force in this fashion, right? After that, this is y3 and this is y2, and as usual this is y1, and we have a by l here, and this is b by l, where a is this span and b is this span 11, and also this is 4. Next, so according to y1 we have a by l. From similar triangle rules, we are finding the ordinates y2 and also y3, and the values of them are 0.2 and -1 by 15 as usual. Next, all the y ordinates are in negative. Now we have to consider only negative ordinates and negative coordinate at C. So as usual, to find the shear force, we know that 40 into minus 4 by 15 plus 50 into 0.2 and 60 into minus 1 by 15. So what are these 40, 50 and 60? These are the loads from the influence line diagram as usual. So the ordinates, the value is minus 24.667 kilonewton. So this is the maximum negative shear force at C. So to find positive shear force, let us suppose that the loads are rolling. For that, load rolled off section, here we have the succeeding span. Sorry for the inconvenience. Now sum of the loads, as usual, span of girder. So as the value is negative, this is maximum negative shear force. And if we have the trial one, this is 13.3, this is not taken, and trial 2, 60 kilonewton load will be on C. So this is also accepted, and the same procedure is repeated as we done like that. So as this trial 2 is satisfied and we are placing 60 kilonewton load at C to find the maximum positive shear force at C, right? So this 60 kilonewton load, this one we are placing at C, and from this diagram, and y2, we know y2 as minus a by l and y3 as b by l. Here you have written y1 here, and as the loads are crossing here, different ordinates can be found like y1, y2, y3, y4, y5 and y6. So the y1 will be minus 1 by 6, and y2, this is minus a by l, as usual we know, minus 4 by 15 here, this is shown. And y3 is b by l, and similarly y4 and y5 you can find them, y6. And after that we have to find the positive shear force at C by multiplying the ordinates with loads, that is 20 into 1 by 6 corresponding 60 into 11 by 15, 60 into 19 by 30, 50 into 0.5 and 40 into 13 by 30. So these are the corresponding loads and corresponding ordinates for that. That is we get 121 kilonewton. So this is the maximum positive shear force at C. So this is very as simple as simple problem, and this is mostly asked question in many of the university examinations. So the maximum negative shear force at C will be minus 24.667 kilonewton, and maximum positive shear force at C will be 121 kilonewton as per the loads that are passing on the passing on a girder, generally in general, as discussed in this problem. So this is a girder of AB, and these are the loads that are traveling from A to B. And considering each load, we get, when we consider this 40, we got a minus value as a shear force. So that will be the maximum negative shear value. And when we consider this 60 kilonewton load, that was a positive value, and that is a positive shear force value. So these type of problems are very important in finding shear force, maximum shear force at C using influence line diagram. I think I am clear in this video. Let's meet in other video with different type of problem. Thank you.